Hello, students. Welcome to today's lesson about the Earth, Moon, and Sun. Today is part 2 of our series and focuses on eclipses and tides. If you think back to our moon phases demo, where we used a plastic ball to represent the moon and a flashlight to represent the sun, there was always one half of that moon in the sunlight, and one half was always in darkness. This is because that dark side of the moon was in a shadow. The sunlight could not transmit through the moon itself. It was absorbed by the moon, and the backside was in a shadow, or an area without light. That same relationship exists between any and all spherical objects in space and our sun. They all block out some of the sun's rays and create a shadow. This happens for both the moon, the earth, and every other planet will create a shadow. Here in this image, you can see a photo from NASA of Saturn and its shadow on its rings. If you look closely at a shadow, though, you'll always find that there are two parts. There's a central, darker area, and then an outer, larger, lighter area. Looks something like this. That flashlight is shining on an object like that plastic ball or tennis ball that we worked with in class. And there's that darker center spot and then that lighter area around it. That darker area where the light is totally blocked is called the umbra. That's going to be your first key vocabulary term. Umbra comes from a Latin word meaning shade or shadow, and it is defined as the central, darker part of a shadow where light is totally blocked. Here in our diagram, you can see the umbra is labeled as that center area, and it appears much darker than the lighter surrounding area. That lighter surrounding area that's outside of the umbra is called the penumbra. And this comes from two Latin words, umbra, of course, meaning shadow or shade, and peini, which means almost. So it means almost a shadow. And it's that defined as that lighter part of a shadow where the light is partially blocked. All objects that have a shadow that block the transmission of light have an umbra and a penumbra. If you look close enough, you'll see those darker central areas and lighter outer areas. That's true both on Earth as well as out in space. When the sun shines on the moon casts a shadow behind it. Here in this diagram, you can see that the moon is casting both a dark central umbra and a lighter, larger penumbra. That shadow of the moon, when it falls on Earth, it creates what we call a solar eclipse. And a solar eclipse is defined as when the moon's shadow appears on Earth's surface. If you're inside the area of the umbra, you see a total eclipse. And if you are inside the area of the penumbra, you see a partial eclipse. Here you can see a total eclipse where that moon has totally blocked out the sun, compared to a partial eclipse on the right, where only a section of the moon is blocking out a section of the sun. And it kind of almost looks like a phase of the moon, where part of it is in light and part of it is in the shadow. If you're outside of the areas of the umbra and the penumbra, you don't see any part of a solar eclipse. The sun just looks normal. The moon's shadow is not over you, so you see the full sun. But why don't solar eclipses happen more often? And it has to deal with the orbits, as well as the phases. A solar eclipse can only occur during a new moon. If you think back to our moon phases demo, the only time the moon was in between the Earth and the sun, where the shadow could fall on the Earth, was in the new moon phase. And It has to be lined up directly between the Earth and the Sun, and this becomes a little bit tricky and rather rare as we look at the moon's actual orbit. The moon's orbit is tilted off of the orbit around the Earth. So there's really only 2 points here where that moon's orbit crosses directly in between the Sun and the Earth. So in the upper right corner of this diagram, you can see that the moon at that new moon phase is too low below the Earth's orbit to be able to cast its shadow on the Earth. In that lower left corner, on that new moon phase where the moon's in between the Earth and the Sun, that moon is too high in its orbit to be able to cast its shadow on the Earth. Only in that upper left corner and that lower right corner is the moon's orbit directly in between the Earth and the Sun. So there's really only 2 points on the Earth's orbit around the Sun where that moon is directly in between that Sun and that Earth. And during those times, it also has to be a new moon. During most of those new moon phases, the vast majority of the time, the moon does not cast a shadow on the Earth. It's above or below the Earth. Just as the moon casts a shadow on the Earth could cast a shadow on the moon. This is what we call a lunar eclipse. Lunar is a term meaning moon. So the moon becomes eclipsed, and this is defined as when the moon moves into Earth's shadow. It makes the moon look something like this. Just like solar eclipses, there are total lunar eclipses and partial lunar eclipses. And then they also happen very rarely because they can only occur during a full moon phase. That's the only time where the moon is behind the Earth completely and the shadow of the Earth could fall on it. And again, it must occur at only certain parts in Earth's revolution when the moon's orbit is directly in line with the Earth. During most of those full moons, the moon is above or below the Earth's shadow. Besides having the effect on the way objects appear, like the view of our sun or the view of our moon, that Earth, moon, and sun can also affect the oceans. The interaction of the moon and sun's gravity affect the rise and fall of the ocean, or what we call a tide. A tide is defined as the daily rise and fall of the sea level. Here in this picture, you can see a place that's called the Bay of Fundy, and this place on the Earth has some of the largest swings in tide levels. It happens to be about a 10-foot change in sea level. On the left, you can see at high tide, and then on the right, you can see it at low tide, and that water is completely dropped low enough that everything is dried up. Now, the way that the moon revolves around the Earth, its gravitational pull kind of warps that water on Earth and causes it to bulge. Remember, gravity is an attractive force, so the moon is pulling on the water and pulling it towards the moon, causing those tides to rise and fall depending on where you're at on the Earth. If you're in line with the moon, it's a high tide. If you are perpendicular to where the moon is at, it's a low tide. When the sun and moon are lined up together, they're in that same direction. Even though the moon might be slightly above or below that direct line that would happen with an eclipse, it creates what's called a spring tide. And they occur during the full and new moon phases when the moon and the Earth and the sun are all lined up in a straight line. This straight line, or the same plane, a spring tide creates larger changes in the sea level because both the sun and the moon are pulling on the water in the same direction. causes extremely tall or larger swings in high tide and larger swings in low tide. There's also a phenomenon called the neap tide, and that occurs when the sun, the moon, and the earth form a right angle, or the sun and moon are perpendicular to each other. This occurs during the first quarter and third quarter phases of the moon, and a neap tide is usually a lower change or smaller change in sea level because the sun and moon are kind of canceling each other out as they pull in different directions. In this diagram, you can see how spring tide, shown on the left and the right, occur. The moon and the sun are pulling in the same plane or the same direction, compared to the neap tide, where the up and down positions of the moon in this diagram are in opposite directions as the sun. If the sun's pulling on the water towards the sun and the moon is pulling in the moon, those tides do not quite end up as large as during a spring tide. Thank you very much for your attention, and I hope you have a wonderful day.